Halogens elements are a group of 5 non-metallic elements and exist as a diatomic molecules. In a modern IUPAC nomenclature, this group is known as group 17. The reactivity of halogens increasing from bottom starting from astatine, followed by iodine, bromine, chlorine, and fluorine. There are 3 types of halogen that will be involved in this experiment. Firstly, chlorine molecule. This element was first discovered by Carl Wilhelm Scheele in 1774. The atomic number of this element is 17, followed by bromine molecule, which was discovered by Anton J. Bellet in 1826. The atomic number of this element is 35. Next is iodine molecule, which was discovered by Bernard Coteus in 1811. The atomic number of this element is 53.
In this experiment, there are 3 main objectives. First, to study the displacement reaction of halogen from its halide solution. Besides, we conduct this experiment as to compare the electronegativity of halogen in displacing a less reactive halogen from an aqueous solution of its halide ion. Moreover, we intend to describe the properties of halogen and its halide solution. Before we proceed, I would like to remind you to always be careful when doing or handling any experiment. The demonstration will be conducted in the fume chamber under the supervision of the lab assistant.
Now, we move on to our experiment. What we need are test tubes, measuring cylinders, droppers, beakers, safety goggles, and rubber gloves. We also have 0.2 mol of potassium chloride solution, 0.2 moles of potassium bromide solution, 0.2 moles of potassium iodide solution, chlorine water, bromine water, iodine water, and last but not least, cyclohexane as an indicator.
Step 1. Pour 1 cm cube of potassium chloride solution, potassium bromide solution, potassium iodide solution into the first row of test tube. Then, add 5 drops of chlorine water into each of the test tubes. Next, pour 1 cm cube of potassium chloride solution, potassium bromide solution, potassium iodide solution into the second row. Add 5 drops of bromine water into each test tubes of the second row. Now, pour 1 cm cube of potassium chloride solution, potassium bromide solution, potassium iodide solution into the last row. Next, add 5 drops of iodine water into each test tubes in the last row and observe the color changes. Lastly, add a few drops of cyclohexane into all of the test tubes. Observe the color changes in the upper layer in each test tubes.
As we can see, this is the result of the experiment.
We can notice that there are two layers in all of the test tube when cyclohexane is added. The upper layer is cyclohexane while the below one is aqueous solution. There are two layers because cyclohexane and aqueous solutions are immiscible.
In the first row of the test tubes, we can see that there are reactions occur in the mixture of chlorine water with potassium bromide and potassium iodide, but no reaction occur in the potassium chloride solution.
When the chlorine water reacts with potassium bromide, the color of the solution changes from colorless to yellow. Then, when cyclohexane is added, the color of the cyclohexane layer is light brown since it detects the presence of bromide. This happens because chlorine water displaces bromide from its solution. Chlorine is more electronegative than bromide, so it can easily displace bromide ion. Chlorine acts as an oxidizing agent, whereas bromide ion acts as a reducing agent. For the reaction between chlorine water and potassium iodide, the color of the solution changes from colorless to dark brown. When cyclohexane is added, the color of the cyclohexane layer is purple. This is because cyclohexane detects the presence of iodine. This is caused by chlorine, which displaces iodine from its solution. The position of chlorine is higher than iodine in the group, so chlorine is more electronegative than iodine, so it can easily displace iodide ion. Chlorine acts as an oxidizing agent, whereas iodide ion acts as a reducing agent.
When bromine water is added into the test tubes, only the solution containing potassium iodide gives a reaction. When bromine water is added into the test tube containing potassium iodide, the color of solution changes from colorless to dark brown. The color of cyclohexane layer is purple when cyclohexane is added into the solution. This happens because cyclohexane detects the presence of iodine. For the solution inside potassium chloride and bromide, the color of cyclohexane layer are light brown. It is because cyclohexane detects the presence of bromine since there are no reaction occur inside both test tubes.
Bromine is more reactive than iodine, but less negative than chlorine, so it can easily displace iodide ion but not chloride ion. This shows that bromine is more electronegative than iodine and acts as oxidizing agent while iodide ion acts as reducing agent. For iodine water, there are no reaction occurs in all the test tubes. When cyclohexane is added into the last three test tubes, all the color of the cyclohexane layer is purple because it detects the presence of iodine since there are no displacement reaction occur.
Generally, halogens are a very good electron acceptor and therefore are a very good oxidizing agent. When going down group 17, the size of halogen atom increases. The nucleus is further away from the outermost occupied shell. Hence, the ability to accept electrons to form negatively charged halide ions decreases. Therefore, become less reactive when going down the group.
In conclusion, a more electronegative halogen can displace a less electronegative halogen from its halide solution, whereby the more electronegative halogen act as the oxidizing agent and the halide ions of the less electronegative halogen act as the reducing agent.